Okay, so let's run through this really quickly. This is just looking at life tables, right? So in the lab, we tried to do, we calculated the growth rate by just looking at one population to the next and how many offspring there were. But this is also one way of looking at it. So we take an organism and we go out and we sample and we see that, in the 0-year-old, 1-year-old, 2-year-old, 3-year-old, 4-year-old, up to 7-year-old lizards, how many individuals did we find? And so you can see in this population there's a lot of young lizards, but as you get older, you're much less likely to survive. So how do we figure that out? Well, we do survivorship. So we assume that if there were 1,000 babies, there should be 1,000 1-year-olds, but we only have 424 1-year-olds. So your chances of surviving to the next year are 42%, and then it drops to 30%, 15%, 5%, 1%, less than 1%. Okay, so that's your survivorship. And then they looked at how many, and actually before we go on, we talk about survivorship, and they can actually do a logarithmic graph of this and see like basically what your survivorship is over over your lifespan. And so type 1 individuals have really high survivorship. They live a long life. And they really just die of old age. So no predators, right? And these are more likely to be K-selected species that wait to reproduce and have really big offspring that compete with each other. Type 2s kind of have a general, like, steady survivorship for their whole lifetime, like birds, right? So they have multiple rounds of reproduction, but their chances of getting offed by a predator are kind of the same throughout their lifetime. And then we have these type 3s. These are really your R-selected species where their chances of surviving are really low. So they have thousands and thousands of offspring because most of them are going to die. And so they have really high mortality at very young ages. So that's your survivorship. So then going back to the table, we can also go and look at how many babies they're having. And it turns out that these lizards don't reproduce until they're about 2 years old. And then as they get older, they actually reproduce more, which is interesting for an R-selected species. So this is your fecundity. So if you take survivorship and multiply it by fecundity, so how likely are you to survive? How many offspring are you likely to have? We can see kind of where the offspring are being produced. So you can see that mostly it's this mid-range. Most of the lizards coming out of this population are coming out of the middle range of ages because their survivorship is fairly high and their fecundity is getting higher. And you can add up all of these average births and you can get a rate. So about 1.0. So it's just maintaining. If it's above 1.0, it's a growing population. If it's below 1.0, it's a declining population. So I gave you some examples from different countries. And you can see, for instance, in Nigeria, sorry, the quality is kind of bad. we have not that many at reproductive age and huge amounts of children. So their birth rates are really, really large. They're a growing population. In Australia, we have about the same amount of reproductive age as youth. So they're about a 1-to-1. So they're just sort of staying stable. And then in Spain, we've got all these reproductive age people, but very low numbers of babies. And so they are a declining population. And then we talked about just some of the cycling and fluctuations. In lab, you did Lotka Volterra, which we'll talk about in class with predator-prey relationships. But then we have this particular case, right, where if you overshoot your carrying capacity, sometimes you'll boom and bust and recover. But in some cases, overshooting by this much will actually cause you to go extinct. It'll just wipe out all resources. And so that's what happened on this island, St. Paul Island, with reindeer. And then you can see what happened with wolves in Yellowstone and how they controlled the elk population. And by simply controlling the elk population, it changed the entire park in landscape and ecology and species diversity and all of it. Pretty amazing.